Stop trusting your AI agents to just, figure it out. My entire purpose in this explainer is to show you exactly why managing your AI skill library is absolutely critical, what a true, good Level 7 architectural benchmark actually looks like, and how you can use it to grab human attention in exactly 1.5 seconds. Let's get into it. Okay, let's dive into this. Our ultimate target here is deterministic system architecture. In the attention engineering framework, we literally call this the M-out trigger, or the transformation payoff. You see, we're skipping all the usual setup and leading right with the flawless final result. Because when you hit this Level 7 benchmark, you completely strip away all that probabilistic guessing you get with standard AI. You're turning execution into a strict engineering problem with crystal clear, auditable inputs and outputs. Every single prompt, every single content hook generated, executes exactly as you intended, no surprises. Because here's the thing. The real danger of unmanaged AI, it isn't that it breaks loudly. It's that it makes these silent, invisible mistakes. It generates content or code that kind of feels right to the human eye, but it completely misses the hidden structural requirements of platform algorithms. So you're just silently bleeding value behind the scenes. Managed frameworks, on the other hand, give you absolute stability and strict guardrails. It's basic loss aversion, right? Failing to manage your AI is just a massive, invisible leak in your entire system. In fact, someone recently told me I wasted $40,000 before realizing this one truth. And man, that is a precise, brutal financial reality. When you ignore the harsh constraints of machine execution and human attention, you don't just lose some arbitrary engagement metric. No, you bleed tens of thousands of dollars in wasted compute, pointless API calls, and completely lost conversion opportunities. It's wild. Now, what's really interesting here is that we are facing a harsh reality we used to call the 3-second cliff. But modern data, it shows that the organic cold start window has shrunk even further, down to just 1.5 seconds. You're fighting this thing called user inertia, which is just the overwhelming human impulse to just keep scrolling. If your AI doesn't generate a hook that shatters that inertia in exactly 1.5 seconds, your content is functionally invisible. It might as well not exist. Let's look at the exact calculus of this critical moment. The probability of keeping a user at that tiny 1.5-second mark literally must exceed the platform's algorithmic threshold. If your cognitive interrupt doesn't instantly counter that exponential human attention decay, the system just marks your output as noise. It kills your distribution on the spot. It's binary, folks. You either solve this equation or you fail. So to beat that threshold, your system needs to deploy highly engineered psychological triggers. We've got outcome, which delivers the final result instantly, loss aversion, triggering that primal threat detection and FOMO, intimacy, hijacking attention through raw peer-to-peer vulnerability, the curiosity gap, providing hyper-specific data but deliberately leaving an open loop, and the authority anchor, combining deep credibility with a sudden pattern interrupt. Listen, these aren't just fluffy marketing buzzwords. These are highly engineered structural interfaces built specifically to solve the human attention bottleneck. So the crucial point is extracting the maximum value. Mathematically, this dictates that in that tiny 1.5-second window, you must never stack these triggers. Seriously, if your AI tries to cram loss aversion, an authority anchor, and a curiosity gap all into the first frame, it just creates massive cognitive noise. It ruins it. You have to pick the single strongest trigger for the specific situation and execute it flawlessly. For example, deploying an authority anchor sounds exactly like this. I've audited 400 systems over 12 years. These 3 tiny details kill them every single time. Boom! You're instantly signaling to the viewer that this isn't some generalized AI-generated fluff. It's hard-earned expertise straight from the trenches. It shatters the pattern and instantly commands the attention you absolutely need to survive that 1.5-second cliff. Which brings us to Section 1, Managing the AI Library, the Critical Guardrail. So how do we guarantee our agents actually execute this math instead of just reverting to generic, boring outputs? Well, we need a critical guardrail. Managing this architecture starts with absolute determinism in how we install our AI's capabilities. First, you run pip install nova act. Then, using the npx skills add command, we pull in a validated repository of skills without any clunky UI prompts getting in the way. It's a precise, non-interactive command line operation designed perfectly for deploying standard behaviors across automated pipelines. And this brilliantly illustrates just how universally compatible this framework is. Whether you're using Claude Code, Cursor, GitHub Copilot, or dozens of others, the CLI automatically detects your installed coding agents. It organizes all these skills into unified directory structures so it knows exactly where to place the instruction sets. It basically creates a single, unified source of truth across all your tools. It's super clean. Plus, you get total architectural control over the scope of these skills. By default, the CLI links a skill directly into your specific project repository. This is absolutely perfect for version control and team sharing, ensuring everyone's AI behaves identically. But if you use a global flag, you can install it straight to your user directory. That makes that specific AI skill available across your entire local environment for literally every single project you touch. And keeping this library maintained? Incredibly straightforward. You just use use to generate a prompt for a skill instantly, list to quickly audit what you've got installed, find to search interactively, update to bump everything up to the latest versions, and remove to aggressively clean up your agents. Running through these CLI operations gives you absolute deterministic control over your AI's behavior matrix, 100% of the time. Now, when you need your agent to execute our specific attention engineering math, you just initialize a custom skill. The sheer simplicity here is fantastic. You just run npx skills init. Boom. It generates a standard markdown file. Then you define the YAML front matter, write out your precise instructions, and that sk.md file becomes the ultimate, unbending instruction set your coding agent will follow without any deviation. Oh, and for enterprise teams building proprietary hooks out there, there's a really smart built-in safeguard. Setting the install internal skills environment variable to 1 exposes hidden skills marked in their front matter. It acts as this essential privacy safeguard, ensuring your half-finished or highly confidential internal engineering tools don't accidentally leak into standard discovery paths. It's a lifesaver. Let's move to section 2 and see how this builds into synthesizing the benchmark, moving from architecture to execution. Right, so now we transition from pure architecture into actual execution through the Hook Validator Checklist. The key here is to treat your AI's content generation exactly like code compilation. Run every single output through this deterministic pipeline before deployment. First up, the zero context check. Literally delete all introductory filler and replace it with your chosen trigger. Second, the pattern interrupt check. Make sure the output actively contradicts conventional wisdom. And third, the hyper-specificity check. Demand exact hard data points. If it fails this checklist, it does not deploy, period. Because at the end of the day, we cannot escape this number, 1.5. It is the brutal, ultimate mathematical bottleneck for both human focus and machine system output. Everything we've built here today, the isolated triggers, the command line interface, the custom skills, it all exists for one reason: to ensure that when your system executes, it strikes with absolute precision inside that 1.5-second algorithmic window. So I'm going to leave you with this provocative question to evaluate your workflows today. Is your current system architecture robust enough to survive the 1.5-second algorithmic cliff? Or are your unmanaged agents silently bleeding value because they lack those deterministic guardrails? It's time to stop guessing and start engineering.